The trig functions using our calculator, so that's our objective for today, to use a calculator to find the values of trig functions. And the absolute first thing we need to do is to make sure your calculator is in degree mode. That's the first thing we need to do. So for degree mode, I suggest you turn your calculator on, and we'll go to the old video cam here, the calculator cam. When you turn your calculator on, look in the display somewhere, and it should give you some kind of indication that you are actually in degree mode. And the calculator I'm showing you, it's pointing to, it actually says DEG for degrees. DEG for degrees. There are two other ways beside degrees to measure angles. One's radians, and we're going to come back to that, chapter 13, section 1. And the other one is gradients, which we are not going to use at all. That's kind of the engineering type person's job. And on this particular calculator, we switch between them with this DRG button. DRG switches, and I'll go ahead and press mine. It's in degrees now, then it goes to radians, then it goes to gradients, and then it's back to degrees. Now, if yours does not say DEG, it might have a capital D for degrees, and if you see an R, then of course it would be in radians. If you see a G, that would be in gradients. So the first thing to do is to first of all make sure you are in degree mode. Otherwise, your answers will not be correct. All right, so to do that, we're going to use our calculators, and unless the problem specifies otherwise, we are always going to round our answers to 4 decimal places. As we're working through the problem, we're going to use 4 decimal places and round it off. Now, I'm going to do the little computer calculator here because I don't think you need to see me pushing buttons. But for the sine of 79.234 decimal degrees, here on this calculator, I'm making sure I'm in degrees. Some of your calculators, you're going to type the number first and then sine next. Some of your calculators, you're going to hit sine first and then the number last. Most of the calculators are the number first. So 79.234. And then we're going to look for the sine button. We're going to hit that. And now your calculator, some of them may go to 8 places, some to 10 places, some to 12 places. This one, I don't know if that's 20 places, whatever. But we're going to round it off to 4 decimal places. So this equal sign with a dot over it means that's approximately equal to 0.9824. 0.9824. And that's all there is to finding the sine of 79.234 decimal degrees. Well, it can't be that easy. And you are correct. It can't be that easy. Because angles, if you remember from chapter 12, section 1, are measured in degrees. And then a degree is not accurate enough, so we break that into 60 equal pieces, each one called a minute. So there are 60 minutes in a degree. And each minute we chop into 60 equal pieces, and we have 60 seconds in each minute. And if you know how to deal with hours, minutes, and seconds, then degrees, minutes, and seconds is going to be no difference. So the first step on this trip is to take the 17 minutes and turn it into a decimal of a degree. Decimal of a degree. To do that, since there are 60 minutes in a degree, we're going to take our calculators, and I don't think you need to see me show you this. We're going to take 17 divided by 60 and round that to 4 places, and that is 0.2833. Where did the 87 come from? Well, we added it to it because it's 87 degrees and 17 minutes, so we're going to add those. So now it's straightforward. We can use our calculator again. Let's hit the clear button. We're going to type 87.2833. Then we're going to hit the cosine button. Round that answer off to 4 decimal places so we'll all get the same answer. And that gives us approximately 0.0474. So far, so good. And you're saying, man, this next test is going to be great. Well, this is not all that's on the test. And guess what the next problem brings? Uh-oh. There's something that's not on my calculator. You can look all you wish, but you will not find a cotangent button on your calculator. No, you didn't get gypped. They don't make cotangent buttons, or if they do, I've never seen one. Cotangent buttons on your calculator. So the question is, what do you do if you're looking for the cotangent of 34.7 and the button's not there? Now, first of all, let me point out something. As long as we got the calculator camera going, above sine is sine to the -1. Now, -1 normally means reciprocal if it's to a number. If you add 1/2 to the -1 power, that would be the reciprocal 2. But in the case of functions, like sine is a function, it means the inverse function. So then above cosine is the inverse cosine function, and above tangent is the inverse. So those are not the reciprocals. So what do? Well, I've been asking you all chapter long to memorize your reciprocals. So who can tell me what the reciprocal of cotangent is? Yes. Well, the reciprocal, what function's the reciprocal? And that is the tangents. So another way to write the cotangent of 34.7 decimal degrees is 1 over the tangent of 34.7 decimal degrees. So now we'll take our calculator. Let's type in the 34.7. We're going to hit the tangent button. We're going to take this answer and round it to 4 places. So 0.6924. Now I'm not going to show you this next step on the calculator, but 1 divided by 0.6924. Now make sure you clear your calculator out. So 1 is being divided only by these 4 decimal places, otherwise we're not going to all get the same answer. And so 1 divided by 0.6924 is approximately 1.4443, and that is the cotangent of 34.7 decimal degrees. So you've got to have memorized which ones are the reciprocals. All right, now that we've used our calculator going forward, it's time to use our calculator going backward to play a little guessing game. We thought of some mystery number. We typed it in the calculator. We hit the sign button. When we rounded it to 4 places, we got 0.7347. Wow. Well, here's what we need to do. We need to find a function that undoes the sine function. That's the inverse function. So let me for a moment go back to this notation, which means that's the inverse function of sine. But before we even get to that, let's just take a little look at inverse functions on our calculators. Remember we had the log button, log, that's base 10. Its inverse function is written right above it, 10 to the x power. Remember we had the natural log button, ln. Its inverse function is right above it, e to the x. And so likewise, the inverse sine function is right above sine, inverse cosine is right above that, inverse tangent is above that. They're in yellow here, and there's a button that's also in yellow, so that means we're going to use that yellow button to get our answers. So we're going to start out by saying the sine of theta is 0.7347. So we're going to take our trusty calculators. We're going to type in 0.7347. And before we hit the sine button, since inverse sine is in yellow, we have to hit this second function button. Then we can hit the sine button. And that's our answer in decimal degrees, not degrees, minutes, seconds, but decimal degrees. 47.28187257. Let's round that off to 4 places. Now, why am I not rounding this one to 4 places? Well, unless you are told otherwise, round to 4 places. This direction says just give it to the nearest tenth. So 47.3 is the nearest tenth. So that mystery angle was 47.3 decimal degrees. So that's the inverse sine button. So far there's 3 relationships we need to know between trig ratios. We need to know their reciprocals, we need to know their cofunctions, And now we need to be able to use their inverse functions. Here's another one. That's the inverse function. And it would be nice and easy if we could just press inverse of cotangent. But there is no cotangent button, so therefore we can't press the inverse of cotangent. Now, again, reciprocals come into play. We need to know the reciprocals of numbers and the trig functions. So here's what I'm going to do. This is an equation. I can raise both sides of this equation to any power except 0. I can square both sides, cube both sides, square root both sides. What I'm going to do without writing it down is raise both sides to the -1 power, or translation, I'm going to take the reciprocal of both sides of this equation. The reciprocal of cotangent is tangent. The reciprocal of 0.4498 is 1 over 0.4498. All right, so let me take my calculator. 1 divided by 0.4498. That's 2.2232. And now we're ready for, and I'm going to use this little one on the computer. Now we're ready to do the inverse tangent. So I'm going to type 2.2232. And on the computer's calculator, there's a little inverse box that you check first. And then I hit the tangent button. And my angle is 65 degrees. And then this is the decimal portion, 0.7816, etc., etc. We're going to round that off to 4 places. So 65.7817 decimal degrees. So this step is actually new from the last example. I'm just writing in that to get theta by itself, the angle, we had to take the inverse tangent of both sides. The inverse tangent of tangent cancels it out, leaves me with the angle. The inverse tangent of 2.2232 gives me the angle theta. However, let's review the directions. They want the answer not to 4 decimal places, but to the nearest minute. So 65 degrees is what it is. But I've got to take the decimal portion, 0.7817, and multiply it by 60. Again, times 60, because there are 60 minutes in a degree. And so that gives me 46.9. If they want it to the nearest second, this would be 65 degrees, 46 minutes. I would take the 0.9 times 60 to find out how many seconds, but that's not what they asked for in this case. They wanted the nearest minute. So 46.9 minutes rounds off to the nearest minute as 65 degrees, 47 minutes. So that's the whole process of going backwards to find out what the angle is. All right, your calculator knows all Scandinavians stand carefully. It knows what's positive or negative in what quadrants, which is nice. So this sine of 253, that's in quadrant 3. And sine is negative in quadrant 3. So if I type 253.4, hit the sine button, my calculator already tells me, yep, it's negative 0.9583. And we round that to 4 places. So approximately negative 0.9583. So that's nice that your calculator knows that sine in quadrant 3 is negative. It knows it's negative in quadrant 3. And that'll help you in this realm. But when we go backwards to find the angle, which we've just done a couple of them, so far all of those angles have been less than 90. So this is where your calculator might frustrate you a little bit, because there are 2 answers to example 5, and your calculator is only going to find the first answer. Now I know you're already thinking, well, how am I going to find the second answer? Well, stay tuned and that will unfold, but let's use our calculators to find the first answer. First of all, cosine is negative. So where is cosine negative? Well, we'll think about that while we start writing the problem out. So cosine of theta is negative 0.5560. We want to take the inverse cosine of both sides. So let's take our trusty calculators here. Let's clear that out. Let me type 0.5560. Now that's positive, so I need to be careful. On most calculators, there's a plus or minus button that'll change the sign from positive to negative and vice versa. So I've got to make it negative. Then I'm going to hit the inverse cosine button and round that off to 4 places. So one of the angles we're looking for is 123.7796 decimal degrees. And they want this to the nearest tenth, so okay, let's make that 123.8 decimal degrees. What quadrant is 123.8 in? 123.8 is in quadrant 2. It's greater than 90, less than 180, so that's quadrant 2. And cosine, yes, is negative in quadrant 2. They want me to find all the answers between 0 and 360, so cosine is negative one other place. It's also negative in quadrant 3. Now, here's the catch about your calculator. If a trig function is negative in 2 quadrants, your calculator will always give you the answer of the first of those 2 quadrants in numerical order. Obviously, quadrant 2 comes before quadrant 3. So it told me the quadrant 2 answer, but it's not going to tell me the quadrant 3 answer. If you had a function that was negative in quadrant 3 and 4, your calculator would find the quadrant 3 answer, not the quadrant 4. So how do we find the remaining answer? Well, here's the trick. Let's find the reference angle for 123 degrees, 0.8 decimal degrees. So start with our x and y axis. Start with our initial side on the positive x-axis. Rotate counterclockwise to our terminal side. There's my 123.8 decimal degree angle. Make a perpendicular to the x-axis. Always the x-axis, never the y-axis. This angle here is the reference angle for 123.8. Well, to find out what that angle is, we have to ask the question, how far short of 180 did we go? And if we subtract, that'll tell us. 180 minus 123.8 is 56.2. Now you're saying, wait, 56.2, that's not in quadrant 3. You're right. So what we need to do is to make an angle in quadrant 3 that has 56.2 as its reference angle. So we'll draw another angle with its initial side on the positive x-axis. We'll rotate counterclockwise. We're not sure how far yet, but this reference angle is 56.2. Now, it's not too hard to figure out what that is. How far past 180 is 56.2? Well, if we take 180 plus 56.2, there's our second mystery angle in quadrant 3, 236.2 decimal degrees. So the two answers to that question is 123.8, that's my quadrant 2 answer, and 236.2 decimal degrees is my quadrant 3 answer. And that's our look at finding trig values using our calculator.